Inside of black hole. Black holes have two parts. There is the event horizon, which you can think of as the surface, though it's simply the point where the gravity gets too strong for anything to escape. And then, at the center, is the singularity. That's the word we use to describe a point that is infinitely small and infinitely dense. University of Chicago Professor Daniel Holz. There are not many cases in physics where we simply cannot predict what happens, but this is one of them. We have a good understanding of what the event horizon looks like, thanks to the laws of general relativity. But as you get close to the singularity itself, we lose the ability to even predict what it looks like. Michio Kaku, world-renowned physicist, had just given a speech that sent ripples through the minds of his audience. However, Michio was not alone in his quest for truth. Among his listeners, a group of bright and curious individuals had formed, the Seekers. Inspired by Michio's speech, they sought the truth behind the cosmos, the technology that was kept hidden, and the secrets that lay within the inside-out black holes. Black holes are fascinating phenomena and enormous cosmic monsters that can have millions of times the mass of our sun. Invisible to us, they lurk everywhere in the universe, and for a long time we knew very little about these phenomena. Discovery of black hole. Scientists think that black holes eventually will explode, but it will take many, many times longer than the current age of the universe for that to happen. What will it look like when that happens? That's another big mystery. How were black holes discovered? The first inkling that anyone had about black holes came in 1930, when young astrophysicist Subramanian Chandrasekhar was mulling over the consequences of several recent discoveries, including Einstein's theory of special relativity. He calculated that all stars larger than 1.4 times the mass of our sun would eventually run out of fuel and collapse. NASA recent work on black hole. Recent observations of a black hole devouring a wandering star may help scientists understand more complex black hole feeding behaviors. Multiple NASA telescopes recently observed a massive black hole tearing apart an unlucky star that wandered too close. Located about 250 million light-years from Earth in the center of another galaxy, it was the fifth closest example of a black hole destroying a star ever observed. A black hole is an astronomical object with a gravitational pull so strong that nothing, not even light, can escape it. A black hole's surface, called its event horizon, defines the boundary where the velocity needed to escape exceeds the speed of light, which is the speed limit of the cosmos. What is a supermassive black hole? Supermassive black holes are so named because they contain on the order of millions to billions times the mass of our sun. Our neighborhood supermassive black hole, the one at the center of our own Milky Way galaxy, is called Sagittarius AE. It's about 15 million miles across and contains the equivalent of 4 million suns worth of mass. Don't worry, it's much too far away to pose any danger to Earth. Another attempt to eradicate the singularity, one that doesn't rely on untested theories of quantum gravity, is known as the gravastar. It's such a theoretical concept that my spell checker didn't even recognize the word. The difference between a black hole and a gravastar is that instead of a singularity, the gravastar is filled with dark energy. Dark energy is a substance that permeates space-time, causing it to expand outward. It sounds like sci-fi, but it's real. Dark energy is currently in operation in the larger cosmos, causing our entire universe to accelerate in its expansion. One star's end is a black hole's beginning. Most black holes form from the remnants of a large star that dies in a supernova explosion. Smaller stars become dense neutron stars, which are not massive enough to trap light. If the total mass of the star is large enough, about 3 times the mass of the sun, it can be proven theoretically that no force can keep the star from collapsing under the influence of gravity. However, as the star collapses, a strange thing occurs. As the surface of the star nears an imaginary surface called the event horizon, time on the star slows relative to the time kept by observers far away. When the surface reaches the event horizon, time stands still, and the star can collapse no more. It is a frozen, collapsing object. Black holes tell us about the universe. Black holes are kind of like a playground for physicists. They are literally made out of space and time, said Professor Holtz. Because they are so extreme, they are the perfect place to test the limits of the rules of the universe. Observing them and thinking about their properties have yielded enormous insights about the nature of the universe. For example, detecting their collisions allowed us to test Einstein's theories about how mass, space, and time are related, as well as lots of other theories about the universe. Black holes also seem to play a role in the formation of galaxies. It's likely our supermassive black hole has something to do with how we came to be here today. Let us know what captivates you the most about these discoveries, and be sure to subscribe for more.